Today we are going to have a lesson on how the wind tunnel is working, as well as what are the parameters are available which is to be looked on. Okay, and for what purpose the wind tunnel is used. That is a very important thing. Okay. Can anyone tell me about for what purpose it is used wind tunnel? Anyone? Aerodynamic effect, that means air flow. Okay, due to the air flow, how an object will behave. Okay, even you have a large size amount of wind tunnel is there. In that, a building, okay, a building structure can be analyzed. How a building can be inserted inside the test section. So here this is called a test section. Okay, so they will have a scale modeling. Okay, scale modeling means 10:1. Okay, or 1:10, 1:100, like that they can have that, but similarity is there. Accordingly, they can do the analysis whether it will instantly that amount of airflow or not. Okay, those things will be analyzed. Here also we can analyze it especially for airman purpose. Okay, then we have a wing, the cross section of wing to create sufficient amount of lift is called the cross section of a wing, which will create a sufficient amount of lift is called airfoil. Here we can use the airfoil to analyze how the lift is produced for the particular airfoil. Whether airfoil is important for lift production?
Yes.
Okay. Because we have a Mach series. We have a Mach series, and each and every port. Here we have a airfoil from the leading edge to the trailing edge. Okay. This is the leading edge to the trailing edge, and there is the lift. Along that you have a number of ports are there with respect to the point to point. At a different position you have at a different position you will have here a number of ports are there. They are all connected with the pressure distribution manometer. Okay, pressure distribution manometer. You can see that 1, 2, 3, 4, 5, 6 like that it will go on. Okay, up to how much ports are there, pressure ports, they are called as pressure ports. It is inserted with this kind of tubes. Okay, so the air will hit on that, and how much pressure is created, that will be absorbed through this tube with the manometer. Okay, can you tell me how the pressure is measured in the manometer? You will have, just look at that. You will have a 1, 2, 3 like that in terms of centimeter. Okay, initially we have to have all the before starting that you have to check whether all the ports are having same levels. Okay, if there are some levels, we can blow it, make it uniformity. Then we can do the operation. First we will have what are the amounts are there. We just come from the side. Can you tell me what is this? It's a rectangular steam tube. Okay. It's a, generally we have a MIT, it's called a honeycomb structure. Okay. But it is a fine tuning, not fine mesh. Is there? Why it is given fine mesh?
Maybe good should not enter.
Then we can close it. We can close it.
Okay, there.
First of all, we should know what type of wind tunnel it is. What type of wind tunnel it is. It is suction type. Low speed wind tunnel. Low speed wind tunnel means the Mach number less than 1. No, very less. Okay, very less. You just see what is the test exercise. You just go and see that test exercise.
300 mm.
300 by 300. Okay, that is the x-axis. What is the maximum velocity? Or maximum velocity can be here. Maximum 30 meter per second. 30 meter per second is given the specification itself. 30 meter per second. Otherwise, it can be at this velocity. What is the speed of the blade? Here we have a motor. Okay, the blade is rotating. The blade is rotating. Okay, and then it will suck the air from that side. It will suck the air. The fan is rotating, suck the air to that side. Okay. There is actually those things are not be closed. That you should be open. Only the air come without any disturbance. Okay. And I know that the way the message is given. If it comes directly in, then it enters into that uniformly. Okay. That means it avoids turbulence. Laminar flow. It will give the laminar flow. Turbulence flow will be prevented because of this mess. Okay. So that is it. You have a convergence section, divergence section. There it starts with the convergence. There it is convergent. There is convergent. Next you have test section. It's a uniform. It's a rectangular section. Okay, model should be placed in the test section itself. Okay, here it is divergent. Okay. Why it is given? What whether the area is converging and the divergence happens? Is there any speed variation?
Yes, sir. To change the airflow pressure.
Definitely the velocity will change. Okay, speed will be affected. Okay, speed will be affected. If the area is divergent happens, what happens then? The velocity or the speed will be dropped down. You note down that the velocity of the nozzle, the output is to increase the velocity. Nozzle will have that is the entrance will be have a diameter higher. Okay, then it goes on decreasing. Okay, then the output object is very small. For that, the area variation will lead to maximum amount of speed. Okay. Okay, one more minute. Okay. Now we have to run the blade. What happens? We can start with the main power. Okay. Then we can increase the. Okay. We can increase the power button. Next, you can increase the stop button is there. Okay. Here is stop button. Okay. You can make it the console is on. Like that you have to use it. Okay. This is for heater. This is for fan. Okay, those things are there. And main thing is here, fan speed is being given here in terms of RPM. Fan speed is given in terms of RPM. Okay. So I want to have the velocity for the airfoil to analyze at 5 meter per second or 10 meter per second, like that. But we don't have measurement of velocity here. We have only RPM here. So that the reference is given. It is due to the carrying axle itself we can identify for this velocity RPM is this much. Like that we can have it. So like that you can have for 15 meter per second velocity. The RPM here to be indicated. We can adjust. Okay, you can adjust the speed of the fan. Then we can nearly 960. Then 15 meter per second. Then you can. Here we have this model is 3-component force here. It is called 3-component balance. Okay, 3-component balance. 3-component balance means 3 things are there. One is lift, drag, moment. So those 3 things will be directly or digitally it will be indicated. once it is right. Okay, and I want to analyze an airfoil with 0 degree angle of attack, 5 degree angle of attack, 10 degree angle of attack, diagonal. So that I can assess at which angle of attack it will give the maximum amount of lift. Okay, so here we have a protect. We can adjust that. So this one initially make it a 0 reference line. Again you can rotate it 5 degree, 10 degree, like that you can make it. Okay. So you have to set and you have to make it right. Then you start the wind. Okay, like that it will go on. Then air will hit on the all pressure force, and here it will go on. But there will be a change of levels in each port. Whether in each port same amount of difference is there? No. Okay. Airfoil at different positions. Okay, pressure ports are there. At all directions, equal amount of air will not be hit on that. Okay, so pressure ports will depend on positions, so that the pressure will change. Okay, so again you can measure for first port, second port, third port. You measure the pressure level. Okay, change of height. From that, how can we find the pressure? Because we have only centimeter. Do you have any relation with respect to what is pressure head? In barometer we have studied. P is equal to P by rho g. P by rho g. That is equal to H. That H is the difference. That is pressure head. Okay, the H equal to P by rho g. P is the pressure, rho is the density of the fluid, whether it is used water or any other fluid or mercury, something else. In fluid mechanics, we have used K, P is equal to rho g H. Okay, density of the fluid you have to use it. So you have to find pressure. Next, you have two things are there. One is P naught and then P is the percentage. P naught represents total pressure. P is represents static pressure. Okay. And how to find the generally we are going to find the coefficient of pressure. Sorry, pressure distribution CP value. Okay, CP value. Have you studied anything else about CP? Not specifically constant pressure. No. You will study the aerodynamics. Okay. There is nothing but P minus P infinity divided by half rho v square. P minus P infinity divided by half rho v square. P is nothing but the pressure at the particular port. Minus P infinity. Infinity refers the fluid, air pressure. Okay. Divided by half rho v square. Half rho v square is nothing but dynamic pressure. Okay. You just have this. You can find the CP value. From the CP value only we are going to make an empirical relation or mathematical relations are there to find the lift also. Accordingly, for each and every angle of attack you can use it, get the CA value. Okay. It's a very first point of view you can use wind tunnel, not this wind tunnel. You can use a larger size wind tunnel. You can use it. This is study is very useful for it. Okay. I have done research in ME in MIT. Okay, it's a very huge wind tunnel. Okay, it will create more amount of noise. Here, not like that. Okay, accordingly, you have to do that. You will see once it is operated. I will definitely explain what it is. Okay. Now, what you will study is nothing but what section is divergent, convergent section, then divergent section. Then which one is similar? That is inlet or that is inlet? This is inlet. What type of inlet is? Suction type. The fan is rotating and it is sucking air. Okay, so suction type. Okay. And what type of three balance component? What is the three balance component? How can we find out the velocity? I want to do an experiment on velocity of 50 meter per second, but you don't have velocity indication. How can you? Okay, by having the RP, okay, so RP will be the percent. So like that you have to do that and find out the coefficient of pressure, then you can find the lift and all the things. Okay, so thank you very much for nice contribution for this. Thank you.